Okay, we will be looking at solving linear equations today. This should be review, but there have been a few questions that I wanted to try to follow up on. So this is going to be a lot of examples and a lot of trying to walk you guys through individually what you should be looking for and what you should be doing step and procedure wise when you have these different kinds of equations that are going to pop up. So let's start with just something simple to begin with, right? So 10 x minus 10 equals a -4. What you're going to do is, like I've told you guys in the past, you need to be looking for the opposite function to get the variable by itself. So since there's only one variable, we're solving for x here, okay? And you have right here, you have a subtraction right here, and the opposite function of subtraction is going to be addition. So to solve for x in this situation, you're going to do x equals, after you add the 10 to both sides, x equals a +6, okay, because you have 10 minus 4, and that's going to equal your 6. Okay, so make sure you think about doing the opposite function in situations like this, okay? And remember, you have to do the same thing to both sides, okay? So if you have an equal sign and you add 10 to this side in the example of this equation, to get rid of the -10 on this side, you add 10 to get 0. You have to remember to add that 10 to the other side as well to make sure that you keep this thing balanced like we've looked at in the past. You have to keep whatever you add to one side, you have to add it to the other to keep them balanced out. All right, so let's look at one that's a little bit more difficult. Let's look at one with some multiplication in it, okay? So you have let's see, 9y equals 81, okay? This is multiplication, all right? I've tried to remind a couple of you guys, anytime that you have something like this, it's really saying 9 times y equals 81. So any situation where you have two variables next to each other, that is the same thing as saying x times y. Any situation where you have a number and a variable, same thing as saying 2 times b. Anytime you have something side by side like this with no operation written in between, that's going to be multiplication. You might see it this way. This is also going to be multiplication. Okay, so this is the same thing as saying 2 times a -4. All right, same situation. All right, so the opposite function of multiplication, all right, if your opposite function up here, you had subtraction, you needed to change that to addition. Your opposite function here, you have multiplication. The opposite function of that is going to be division. Okay, so you're going to do y on one side of the equation. You're going to divide both sides by the number, right? Because you want to get the y by itself. You're trying to isolate that variable. To do that, you need to divide by the number. So you would divide both sides by 9. This would become 1, which means your 9s would go away on this side. And 81 divided by 9 is just going to be 9. All right, so I don't want you guys to freak out and overthink things too much. That's kind of what it seems like has been happening a little bit in some of the lessons. Okay. Another place where you guys tend to get stuck is if you have something like y over -2 equals +8. Okay, y over -2 equals a +8. Now, what this is telling you to do All that this is right here, this is division. Okay, this is division. How do you get rid of, even if it's not division, even if you want to think about it in a fraction, how do you get rid of something on the bottom? If you have 1 times a negative 2 and you want to get that value to equal 1, because that's how the identity property of multiplication works, you need to get something to equal 1. What will you multiply it by to get something that's going to equal 1? Well, you multiply it by its reciprocal, which in this case would be negative 2 over 1. Your negative 2's would cancel out, your 1's would cancel out, okay? And you would be left with 1. The other way to look at it is they wouldn't cancel out. You would get 1 times a negative 2 over negative 2 times 1. That's going to equal negative 2 over a negative 2. Negative times a negative, or negative divided by a negative, is going to be positive. Anytime you have the same number above and below a fraction sign, it's going to equal 1. All right, so that's another way that you can think about this. So in this situation, you have y over a negative 2. Okay, so you're going to multiply this by its reciprocal. All right, you want to multiply this by negative 2 over 1 to get rid of the negative 2 that's on the bottom. Now you need to do the same thing to both sides. So you have negative 2 over 1 times 8 over 1, all right? And you would be left with y, because the negative 2 over negative 2 would become a 1, so it's just y, equals 8 times a negative 2, which is going to equal a negative 16. So in this situation, y is going to equal a negative 16. Okay? Similar yet different kind of situation. If you have something like 2/3 x equals a positive 9, same idea that you saw up here, all right? And I suggest anything that you see me writing in light blue, you add to your notes, because these are going to be general principles that you're going to keep using. But the same idea is up here. You have a fraction, okay? Another way you could have written this example up here with the y over negative 2 would have been negative 1/2 y. It's the same thing, all right? In this situation, you have 2/3 x, and you're going to, again, if you have a fraction, you want to multiply that by its reciprocal, okay? So the reciprocal of 2/3 is going to be 3 over 2, okay? 9 over 1 times 3 over 2, and you would be left with x equals 9 times 3 over 2, which is going to equal 27, over 2, okay? So you have 27 over 2. Can that be reduced? The first thing you need to look at is, can it be reduced? And in this situation, the answer is no. This cannot be reduced. So you're going to leave this in this form, okay? So x equals 27 over 2, okay? So to give you an overview of what we've done so far, all right, what we've looked at this far, you need to you're going to want to think about the opposite function, okay? Think about your opposite function. So when you have addition, it's going to be subtraction. If you have subtraction, it's going to be addition, okay? If you have multiplication, it's going to be division. And if you have division, it's going to be multiplication. If you have an a over b, it's going to be multiplying it by b over a. Okay? And if you have a variable over a number, it's going to be the same as multiplying by that number that's on the bottom. All right? So you're thinking about the opposite function, and again, you need to do the same thing to both sides. So if you add something to one side, you have to continue to add it to the other side. You can't just leave it and say, well, that's good enough. I did what I had to do. There's the math portion of that right there. I'm all set. You can't do that. You would be changing that equation. It would no longer be an equation. You would be changing the overall value of what that problem was, and you can't exactly do that. So let's give you guys one more that some of you had a hard time working with, okay? So if I tell you to solve for y, and I give you the equation of 3x plus y equals positive 10. If I give you that equation, I tell you to solve for y, this is the item that you're trying to isolate, okay? So what you're going to look at is you're going to look at, and you're going to be looking for whatever function is nearest to or associated with that y, okay? So what function, what operation comes right before the y or right after the y? Well, there's nothing that comes after the y, so what comes right before the y is addition, all right? So you have addition. So the opposite function of that is going to be subtraction. You're going to be subtracting something. What are you subtracting? You're subtracting what comes before that addition sign, all right? So you're subtracting 3x. You have to do the same thing to both sides. So you're subtracting 3x from both sides. Okay, so make sure you look at whatever operation goes with the variable that you are trying to solve for. So in this case, you're looking for the variable y. You want to solve for that. So you want y by itself. The operation that goes with that is addition, okay? So you're going to subtract 3x from both sides, which is going to give you a solution of y equals negative 3x plus 10. All right, some of you are probably wondering, why was it written that way? Typically, the format that you want to write any kind of equation in where you have an x and a y, if you have an xy, you're going to be writing it y equals whatever number is with your x plus whatever the other number is, all right? So you always list the x first on this side of the equation if you have the y separately. Okay, so you're making sure that you write the x first and then the numbers, all right? Let's give you one that's a little bit more difficult than that, and then we should probably be able to wrap this up, all right? I want to give you guys a couple of examples because you're going to keep seeing this. Again, you're solving for y. You have 9x minus a 3y equals 15, okay? So again, what you're looking for is you're going to look for the operations that are associated with the y, all right? So you have subtraction here that's associated with the y, and remember what I told you before, anytime you see a number right next to a variable, that is going to be the same thing as that number times that variable, okay? So you have subtraction here, so the opposite function of that is going to be addition, so you're going to add the 9x, and you're going to add the 9x to both sides, okay? So that would give you a negative 3y equals 9x plus 15. Okay, remember that you write it in this format. Okay, now you have multiplication still. And so you have this function right here, okay? This implied function that's in between the x, that y and the negative 3 is going to be multiplication. So your opposite function of that is going to be division. All right, and to divide this number out, okay, you divide both sides by a negative 3. Divide both sides by a negative 3, you would get y equals 9 over negative 3 x plus 15 over a negative 3. Okay, you have fractions here. Can you simplify or reduce those fractions? Yes, you can. You remember you have a negative on the bottom, so this value is going to stay negative. 9 divided by 3 is going to be 3. 3x. 15 divided by 3 is 5. The negative stays. All right, this negative is going to stay, so minus 5. So the solution to this one would be y equals negative 3x minus 5. All right, so what you want to keep in mind, all right, some things you're going to want to keep in mind are the opposite function. All right, writing out a y equals kind of scenario in y equals ax plus b form. All right, anytime you have a number in a variable, it's the same as saying the number times that variable. Any kind of situation where you have solve for one variable and there are two variables, you're isolating that single variable. So you're treating the second variable just like you would treat a number in those simpler problems, right? You're going to add or subtract it from both sides, divide it from both sides, whatever you got to do. So you need to make sure that you remember to keep your equations balanced. All right, anything you do to one side of the equal side, you must do to the other. You don't want to be messing with that, okay? As soon as you multiply something by one side, you've completely changed the equation, so you need to do the same thing to the other side. The properties that say that you can do this, all right, these things right here, these are your identity properties. Okay, your identity properties. And what those say, all right, is a plus 0 equals a, but also more importantly, a plus a negative a equals 0. Okay, so when you have addition, your identity is 0. Okay, when you have addition, your identity is 0. When you have multiplication, your identity is 1. Okay, so what you're looking at here is you're looking at these two things, all right? The identities of addition, where a plus a negative a is going to equal 0, and the identity of multiplication, where an a times a 1 over a is going to equal 1, okay? And that is going to be the same for a fraction as well, all right? The identity of a fraction, is going to be its reciprocal, okay? The identity of a fraction is its reciprocal. So a over b, to get the identity of that, you multiply by b over a, okay? So just want to clarify some of these things for you guys so that you can get a little bit more solid on this principle.